Okay, we're going to look at on page 415 in your book. We're going to see a couple more problems that are going to look similar to the ones that we just discussed. We have, first of all, sine inverse of 1/2. I'm going to get a couple more examples here of using the sine inverse. Okay, once again, unit circle because of the 1/2 is a nice number. Okay, sine would be 1/2 at that point right there. Okay, also that point right there, which would be pi over 6 and 5 pi over 6. Okay. And so our issue then is which one of those is the right answer, because again, sine equals 1/2 at both of those points. So which one's the right answer? And the answer is the only one that's between negative pi over 2 and pi over 2. So which one is that then in this case? It would be the pi over 6. Okay. If we did sine inverse of negative radical 3 over 2, okay, then our choices in that case, negative radical 3 over 2, okay, would be when the sine is long, which would be right here and right here. Those points are 4 pi over 3 and 5 pi over 3. However, neither one of those are between negative pi over 2 and pi over 2. So like we did in that previous example, we'll go backwards. This is going to be negative pi over 3, negative 2 pi over 3. And again, which of those is between negative pi over 2 and pi over 2? It's the negative pi over 3. Questions so far on making that determination? All right. Okay. The next one we have is sine inverse of pi over 2. Okay, so sine inverse of pi over 2. Now here's one you got to be a little bit careful with here, because if we want sine inverse of pi over 2, remember that would come from sine of theta equals pi over 2. Okay. Remember, as a decimal, pi is 3.14, and if I divide that by 2, it would be 1.57, right? Again, rounding. Okay. So if it's 1.57, I want you to think about what we know about the sine function. If I were to draw that sine function, how high and low does it go? It goes up to 1 and down to negative 1. If I graphed 1.57, okay, when would those intersect? Would they ever? No. So is there an answer then to this question? No. Okay, we would say in this case does not exist. Okay. We can't find the sine inverse of pi over 2 because the sine doesn't ever equal pi over 2. Fair enough? Okay. All right, let's look at D on that problem is the same one as we had earlier here, just pi over 9. Okay, so we know that in this case, these two will cancel each other out as long as the argument is between negative pi over 2 and pi over 2, which it is. So in this case, it's simply pi over 9. Okay. All right, now let's go to this one here. This is the one that we have to make an adjustment for. Okay. So we might say the answer here is 5 pi over 6 because we'd say, oh, those just cancel each other out. Nope, not this time. Because if we were to do that and we put 5 pi over 6 down, is 5 pi over 6 between negative pi over 2 and pi over 2? No, then that can't be the right answer then. Okay. So what we need to do is work from the inside out with our unit circle. Okay, determine what the sine value is at 5 pi over 6. 5 pi over 6 is right here. Okay. And the sine value then would be the small one. So we'd want sine inverse of 1/2. Okay. So we'd basically just figure out what's the sine of 5 pi over 6 and put that number in there. And now we would start fresh just as if it was one of these types of problems we did up top. Okay. And so now I need to know sine inverse of 1/2, okay, which means that my two options are pi over 6 or 5 pi over 6. We know that 5 pi over 6 is not in the range, so therefore what's the final answer to this? It's pi over 6. So this would be an example of, and we use that table that we just looked at, where the answer is not just the argument. Because if you put the argument as the answer, that's not going to be right because it's not in the range. It's got to be in the range in order to be right. Ashley?
Since there's always two options, is it possible, because it's 5 pi over 6, since there's always two options, is it possible that it's just always the other number?
The only problem though is that, you know, when you're dealing with sine, cosine, and also tangent here, you know, you're not always dealing with the first and second quadrants. Okay, so like tangent, it might be in the first and third, so you got to be careful with your positives and negatives and so on. So I would always draw myself a picture and put the two options on there and just see which option works. And like I said, when we're in these two quadrants here, the two positive options never work, do they? So we always have to get the negative ones too. So I personally would always draw a picture. That way I'm pretty much 100% sure that I got the right one. Okay. Like I said, if you put 5 pi over 6, that might seem like it's the right answer, but it's definitely not, because that 5 pi over 6 is not in the range. Okay. All right. Let's take a look next at the inverse cosine function. Okay, the key element here with the inverse cosine function, and the work that we're going to do with this and the tangent is going to be exactly the same as what we did with the sine. Okay. The rules that we're going to play by, though, is that for the cosine function, we restrict it from 0 to pi, negative 1 to 1, of course. And so, therefore, the domain of the arc cosine or inverse cosine is going to be negative 1 to 1. The range is going to be from 0 to pi. Okay, and this is what the graph looks like. Keep in mind that your calculator will graph this. Okay, if you set the window up right, it will graph this function. So if you forget what it looks like and it's a calculator problem, you can always graph it again and see. Okay, and as I pointed out in the last one, the key element here is the range of the inverse cosine. Okay, the range of the inverse cosine is 0 to pi. So therefore, if you have a cosine inverse problem, like say cosine inverse of negative 1/2, for argument's sake, and we want to figure out what that is, I would once again make my unit circle. Okay. Cosine would be negative 1/2 at that point, and at that point, which would be 2 pi over 3 and 4 pi over 3. That's where cosine would equal negative 1/2. And the question is, are either one of those between 0 and pi? The 2 pi over 3 is, isn't it? 2/3 is between 0 and 1, isn't it? So we'd say it's 2 pi over 3 in that case. Okay. Now, could it be possible that we have one where we'd have to find the negatives of these two also because they might not fit? Or what's the range? 0 to pi? Would we ever have to find the negatives in this case? Would any negatives ever do us any good? No. So with the cosine, we don't have to do the negatives ever because the negatives aren't ever going to work, are they? Okay, the only answers that could possibly work here have to be between 0 and pi. Fair enough? Okay. All right, and then with the tangent function, we restrict the domain between negative pi over 2 and pi over 2, the two asymptotes. Okay. Keep in mind that the tangent's domain then is negative pi over 2 to pi over 2. The range is negative infinity to infinity, because we know that these keep going. Follow the asymptotes up and down, if you will. So we should expect then that if we do the opposite of that, then the domain is going to be negative infinity to infinity, and that is a fact. Okay. The range is negative pi over 2 to pi over 2. Notice the horizontal asymptotes this time instead of vertical asymptotes that we have here in this picture. Okay. So that tangent has horizontal asymptotes at y equals pi over 2 and y equals negative pi over 2. Okay. So we can also say, just using some of the information that we have been working with in the past, what would be the answer to that question then? What would be the limit as tangent inverse approaches infinity? Okay. The end behavior would be it gets closer and closer to pi over 2. And when we go towards negative infinity, the tangent inverse gets closer to negative pi over 2. Okay. Again, indicating those horizontal asymptotes that we see in that graph. Okay. And in dealing with a tangent inverse problem, we're going to follow the same domain, or excuse me, follow the same range as we did for the sine. Okay, so both with sine inverse and tangent inverse, okay, our restricted range here is negative pi over 2 to pi over 2. And the cosine is 0 to pi. Questions so far? Alright, so I want you to look at page 417 in your book at this point. We're going to take a look at a couple other problems similar to the ones that we've been working with here. So the first one is cosine inverse of negative radical 2 over 2. So to handle that, we know negative radical 2 over 2 is one of our special values. So cosine would be negative in the second and third quadrants. Radical 2 over 2 we know is a pi over 4 value, so it would be 3 pi over 4 and 5 pi over 4 would be our two choices. Okay? And once again, we just need to ask ourselves which one of those is between 0 and pi, which is the range of the inverse cosine. So which one's between 0 and pi? It would be 3 pi over 4. Okay? And that's it. And if you understand the unit circle, then these problems are not any more difficult than just finding the tangent, sine, cosine of a particular angle, are they? Okay. Let's do, how about tangent inverse radical 3? Okay. So keep in mind if tangent were radical 3, that would be the radical 3 over 2 over 1/2 situation, okay, which would mean it would have a big sine, small cosine, okay, which would be big sine, small cosine would be here at pi over 3. And tangent being positive here means that it could be in the third quadrant also, so it could be here at, let's see, what was it, 8 pi over 6 would be 4 pi over 3. Okay. So it's got to be either that one or that one. And remember with tangent, we need to pick the one that's between negative pi over 2 and pi over 2. So it can't be that one. And pi over 3 is between negative pi over 2 and pi over 2. So once we determine the right location, should be a piece of cake, right? Alright. And the last one on that page 417 that I mentioned, we have cosine inverse of cosine of negative 1.1. Okay. Now, here's a composition one again, and we might say, okay, well, it's negative 1.1. But the problem is cosine inverse range is 0 to pi. So does negative 1 to 1 work, or negative 1.1 work? Doesn't work, does it? Okay. And that's not a nice value either. So at this point, we'd really have no choice but to use calculator. Okay, so if we do cosine of negative 1.1, we get that 0.45, 453, so on. And then if we do the inverse cosine of that, we would get our answer, which is 1.1. Okay. All right. So notice it is related to that value. Okay. But it's not the value itself because again we can't have that there. Now I want to illustrate how we could have done that without the calculator. Okay. So if we had a value of 1.1, okay, which would be either in the in either of these quadrants, okay, cosine of negative 1.1, the value of negative 1.1 that is. Cosine value, we're going to have to be over here in either the second or the third, right? Okay. But remember, in the second and third, the cosine is going to be negative. Okay. If we were to get an equivalent value, okay, that's between 0 and pi, okay, it would ultimately have to be the positive of that. Okay. Think about it. If I did negative 1/2, pick a simple one. Okay. So if I had cosine inverse of negative 1/2, we know the answer is not negative 1/2 because it's not in the range. But cosine being negative 1/2, okay, would be here and here. True? All right. So it would be in those two, which would ultimately give us either 2 pi over 3 or 4 pi over 3. Okay. And then when we do the cosine inverse of those two, okay, the result, okay, again, is not going to be negative 1/2. Okay. If we do the same thing we did in the last one, if we do cosine of negative 0.5, okay, we're going to get that. Okay. And then if we do cosine inverse of the answer, okay, we get the positive of that, don't we? Okay. All right. So we could make a generalization at this point. Is that going to work every time with the cosine and the cosine inverse? If we do the cosine of a negative value and then the cosine inverse of that, is it always going to give us the positive? Seems that way, doesn't it? Seems like the pattern that we're developing here. So if I have cosine inverse of cosine negative x, okay, that should equal, according to our pattern we've just developed, it should equal what? Should equal the positive of that, shouldn't it? All right. Questions so far? Alright. Okay, a couple final parts here. When we have a triangle as such, okay, with our theta here, one hypotenuse x leg, we could figure out the value of the other leg by the Pythagorean theorem here. Okay, and what they've asked us to do here is compose each of the 6 basic trig functions with cosine inverse x, okay, and reduce the composite function to an algebraic expression with no trig functions. Okay, so we're going to do, ultimately we're going to compose, instead of it with just cosine x, we're going to do it with sine x. Okay, so I'll show you the next page what we're after here. Okay. So what we're really after is this. We want to, instead of doing cosine inverse with cosine, okay, we're going to do cosine inverse with sine, because we can combine inverses with other trig functions besides just the one that it came from. Okay, so think about how we would get this. Okay, now what I want you to think of here is this. Okay, if I have cosine inverse of x, okay, so if I have cosine inverse of x, keep in mind that x is a value. Okay, the inverse that we get out is an angle. So really, in that sense, then aren't I really just doing sine of theta here? Because remember, the cosine inverse of a value is an angle. Fair enough? And so when this problem, I'm doing the sine of some angle, okay, equals what? In this case, the angle here in question is this one. And why is this the answer? Because what's sine? Opposite over hypotenuse, isn't it? Okay, and hence we get that as our answer. Similar here, once again, this cosine inverse is going to be an angle. So if I do the cosine of that angle, I'm going to get adjacent over hypotenuse, which is x. Okay. And then when I do tangent of that angle, because remember again, cosine inverse represents an angle. Okay, what angle? In this case, it's the angle theta. So if I do tangent of theta, that's going to be opposite over adjacent. So square root of 1 minus x squared over that, over the x. Okay, and then of course if I do secant, cotangent, those answers are all just going to be the flips of the ones that we did on the left. Fair enough? So again, is it possible to recognize a trig function of an inverse of a different trig function? Absolutely. Okay, so we're going to have a couple problems from our homework where we're going to do just that. Okay. Alright, so for tomorrow, we're going to go ahead and work on our assignment here for section 4.7. So, as always, send me problems on email, and we'll work with them tomorrow.